Good afternoon. So, apologies, I'm going to have to speak in English. I don't speak Swedish, I'm afraid, but initially I was going to talk about some of the ultrasound physics, but Margarita and Mikael have already gone through some of that, so whilst I was trying to understand some of it in Swedish, I'll try and avoid any duplication of what they've already covered. So if I do duplicate something, please just shout and say, we've done this, and I'll move on. So I work for IMV, based out of our office in Scotland, which is the head office of all our imaging. So we're in UK, Netherlands, Belgium, Sweden. Predominantly, my role is CT and MRI, but I started in 2001 with a company called BCF Technology, which later became IMV Imaging. And we started in 1983, and we developed some of the first animal ultrasound systems. And that was for sheep scanning. So it was founded by three guys who'd worked in Glasgow, where ultrasound was created, or developed, I should say, not created, through various meetings between the Navy and obstetricians at a dinner party, allegedly. So we developed the first sheep scanner there, and later developed a range of cattle scanners and equine systems. And 40 years later, here we are with CT, MRI, state-of-the-art ultrasound for small animals and equines as well. So I'll try and give some sort of background on the types of systems and probes that we're using. So, objectives to acquire images of good diagnostic quality with ultrasound. There are three contributors to this. One is the machine. So if you're using a really old machine or an unsuitable machine, you're not going to acquire images of a diagnostic quality. The other important aspect is the animal. Different animals will image differently. If I use an equine comparison here, scanning a racehorse, a thoroughbred's leg, is very different to scanning an Icelandic horse's leg. There's been a lot of small animal references, so I thought I'd bring some equine into the mix. Icelandic horses, really thick skin, very difficult to scan. Whereas thoroughbreds, very thin-skinned, easy to scan. And the third most important factor in acquiring good images is you. Technique and learning, so CPD, there's so many routes available these days. We have a lot of online materials on our website, so by all means have a look on there. There are various courses you can run online as well. But getting hands-on is probably the best way. I advise you all to get as much hands-on experience as you can. I think there was some discussion earlier about what is ultrasound, but just as a reminder, we're looking at greater than 20,000 hertz. And typically most ultrasound probes now will run anywhere from 1 to 20 megahertz. The frequency range is very, very broad now. And over the years, it's got higher. We've used higher and higher frequencies now. When I first started 20 years ago, we would never dream of scanning animals at 12, 13 megahertz. That was getting into the realms of ophthalmology. But these days, we have linear probes that go up to 18 megahertz and give beautiful superficial imaging of adrenal glands, kidneys, or on legs for flexor tendons. Did anybody discuss how we make ultrasound earlier? No, okay, I'll get into my physics, geeky nerdiness here. It's made by piezoelectric crystals. That's not really working on there. These things. And when we apply voltage to a piezoelectric crystal, it deforms, its shape changes. And that rapid shape changing interacts with the probe materials to produce the ultrasounds going out. When those ultrasounds encounter tissues of differing densities or acoustic impedance, a reflection happens. And when that reflection comes back, it hits the crystal, and it's a reverse process. The crystal is deformed by the ultrasound and produces a voltage. And all the ultrasound machine is doing is measuring that voltage and assigning a shade of grey to it. Now, I've greatly simplified that, and some of my physics buddies back in Scotland will be they go into a lot more depth on that, but you don't really need much more. So we talked about acoustic impedance. I think there was some mention of these values earlier. One of the things that is great about ultrasound is that all of these tissues, even though the values of the impedance looks very, very small, they're all sufficiently different enough that assuming the machine's set up correctly, you can tell the difference between liver and spleen and kidney. They all have sufficient differences in their grayscale values. What gets really interesting is bone and air. So bone conducts sound very, very well. If you only got to think of a table, if you put your ear to the table and scratch the table, the sound travels incredibly well. Whereas ultrasound is very, very weak and won't travel through air. The fact that this is many, many times greater and this is many, many times smaller is why bone and air look the same on ultrasound. Whereas in radiography, they don't, do they? I know I'm referring back to this, but it is an important feature. You need to think about what probes and what frequencies you're using that are suitable, not just to the animal, but to the anatomy of that animal as well. What are you scanning on a large dog? If it's superficial, do you really need a low frequency probe? Probably not. This is a little drawing that one of my colleagues has done. We're fortunate we've got about 12 vets work for us in the industry, in the business, and they're constantly producing these learning materials. So please get on the website, have a look at the learning and development section. It's showing you. So if we get high frequency signals, we can image superficial. But if we want to go that bit further, you need lower frequencies. And what we mean by low frequencies in small animal would say be 1 to 5 megahertz, and maybe 5 to 10 as being the higher frequencies. But then some of the linear probes, we work 15, 20 megahertz. They're very, very superficial structures. Just to bring a bit more equine focus into it. So, yeah, if you're scanning a leg, you're scanning flexor tendons. You know, for these flexor tendons, SDFT, DDFT, you may be scanning these 12 megahertz. But things like the suspensory ligament, it's quite often 8 or 10 megahertz. But again, it depends on the horse. Your thoroughbred's going to be different to the Icelandic. So I just wanted to go through some of the transducers, just terminology and understanding what we mean. For small animal use, a microconvex is essential. This is your bread and butter of scanning for abdomens. What you're looking for in a microconvex is a nice tight curve so that you can fit it between the ribs quite easily, and then it'll open out wide within the animal. And a good frequency range as well is of importance, unless you want multiple probes. Most good microconvex probes now will run 5 to 10 megahertz, something along those lines. This one goes 4 to 11. And with just that one probe, you can actually scan most dogs and cats. And with some good clipping on the flanks of large dogs, even with this one, you can still get in and image most animals with it. I can say this now that Michael's gone, but you can use this for cardiology. Generally speaking, the Doppler will be awful for cardiology because it's too slow. These probes are not designed to image quickly. They're designed to give high quality images, not high speed, high frame rate images. So yes, you'll get lovely color Doppler in the abdomen, but as soon as you put it on a heart, it'll look like somebody spilt a tin of paint over the screen. But for normal B mode imaging and for M mode imaging, it's absolutely fine. So you may get some rib shadow, but it's not a great deal. It's something that can be worked around. Yeah, so all your parasternal 4-chamber axis, short axis views, all achievable with that. There is a larger convex probe available for all systems, and these are typically what's used in human medicine for abdominal scanning. And if any of you have to go to a scan with an abdomen or pregnancy scanning, there'll be something along those lines, 1 to 5 megahertz. We sell very few for small animal use. What we sell more of now than we ever did in small animal is linear probes. And linear probes are really, really great for superficial imaging. And Margarita showed some beautiful images earlier using something like this with a 12 megahertz linear. But we also do some hockey stick probes which go up to 18, 20 megahertz. And they're amazing for things like cats or we're talking about exotics works where you want to image really superficially to high quality. But also for ophthalmology as well. So you can scan, obviously with this sort of probe, but a smaller linear just allows better rotation, and a higher frequency gives better resolution as well. And then lastly, probes, phased array. So I know that Michael talked about phased array probes. Most systems you get a minimum of 3. A low frequency one like this, which you'd use for large dogs and horses. It's also very useful for subcostal views. So quite often if you're wanting to measure the blood velocity in the aorta, and the aorta's coming down the animal, you want to hit it head on. You're generally going through quite a big distance there. So for that reason, something like a 3 megahertz is a really good tool for that. But if you're not doing a lot of large dogs, that's probably the one to drop, and then look at something like a 6 megahertz, which will do most dogs for parasternal images left and right. And then something higher, if you're doing small dogs and cats, this is a 12 megahertz. Absolutely beautiful on cats, but you're probably going to be limited to certainly less than a 10 kilo dog. Probably even like an 8 kilo dog will be a limit with that. And then for equine's a little bit more simple. That's not a microconvex, that's a linear probe. That's a microconvex and that's a convex. Honestly, I do know what I'm doing. So the linear probes, generally for leg scanning, flexor tendons, suspensories, all the musculoskeletal, and a rectal probe there for reproduction. A microconvex is a little bit of a luxury for equine work. Sometimes nice for necks, because it'll give a very, very wide view of the neck, and superficial abdomen. But the big two probes that most people buy is a convex probe and a linear probe, because this will give beautiful abdominal imaging. But there's also quite a lot of musculoskeletal applications in these, so for necks and backs. In the UK, we have a large racehorse population. We get a lot of ilial wingtip fractures. Obviously, that's not something you can easily x-ray in a horse, but you can use ultrasound to see the fracture. You'll see the bone, but you'll see a step in the bone. So you can use it for... You have to be creative with horses, don't you? And then lastly here, just some of the different types of ultrasound we sell. I've worked with GE for 20 years now. They're my go-to favourite, if you like. They're the highest quality that we provide. But if you're wanting to get the price down, we also work with this company here called Vino, who've really got some good packages together. We can put them on carts as well, so we do multiple probe carts as well. So if you're wanting to buy lots of probes, you can connect 3 probes at the same time and then just change them through the scanner. But then also think about what features are you going to need now and in the future. Are you going to need colour and Doppler? Are you going to want to start doing more cardiology? In which case the Vino's probably not the one for you. You probably look more for GE for future-proofing with cardiology. Doppler, DICOM networking is a useful tool these days. The ultrasound images now are great for sharing images. You know, we can export them to USBs, but we can also send them to PACS systems, so it automatically archives all your images. Are you going to want an ECG? So you can connect an ECG to most of these systems. The ECGs, they're not diagnostic ECGs, so they're usually a 3-lead set, and really they're there just to understand where to take your measurements. Is this diastole? Is this systole? This is where I'm going to take the measurement. You wouldn't use them as a diagnostic tool in itself, but it's something worth looking at if you're branching into cardiology. Last thing you need to consider is support. There's no point buying these ultrasound scanners, not having the people to train you, not having the service support. So we are now based directly in Anglehome. We have loan equipment there. I'm coming over pretty regularly at the moment, but Jessica is learning quickly as well. And as the business grows, we'll offer more and more insight support. So there we are. Thank you. We'll have some of the machines at the back. Chris is going to give a talk about endoscopy now, and then we'll have some hands-on session where you can try and scope the dogs and scan Sally and Jolly. Thank you.